What if the coldest, most forgotten world in our solar system has been hiding a secret for 4 billion years, and we only just built a tool sharp enough to catch it? Just days ago, a telescope designed to stare at galaxies from the dawn of time turned around and looked at a tiny frozen dot right here in our own solar system. What it found doesn't just add a new fact to the Pluto file, it rewrites the whole story. Before we go any further, hit that like button like you're flipping a switch that keeps this channel alive. Subscribe if you to stare at galaxies from the dawn of time turned around and looked at a tiny frozen dot right here in our own solar system. What it found doesn't just add a new fact to the Pluto file, it rewrites the whole story. Before we go any further, hit that like button like you're flipping a switch that keeps this channel alive. Subscribe if you want to keep chasing mysteries like this one. And send this to the one friend who still thinks Pluto is just a boring ice ball nobody cares about. They're about to be very wrong. Let's go back to the beginning, because this story doesn't start with James Webb. It starts in 1930, with a young astronomer named Clyde Tombaugh staring at photographic plates night after night, hunting for a ninth planet that other scientists were convinced had to be out there, tugging faintly on the orbit of Neptune. He found it, a faint, moving point of light billions of miles away, barely more than be out there, tugging faintly on the orbit of Neptune. He found it, a faint, moving point of light, billions of miles away, barely more than a smudge against a field of stars. Newspapers around the world ran the story, a new planet discovered by a 24-year-old who hadn't even finished college yet. For decades, Pluto sat quietly at the edge of our maps, a planet in name, a mystery in truth, too far and too faint for even the best telescopes of the 20th century to make out any real detail. Then, in 2006, astronomers gathered and redrew the rules of what counts as a planet. Pluto didn't meet the new definition, mainly because it hadn't cleared its orbital neighborhood of other debris. It became a dwarf planet, smaller, lesser. Almost an afterthought in classrooms and textbooks overnight. People argued about it, some still do. But while humans were busy debating a label, Pluto kept doing whatever it had been doing for billions of years, completely indifferent to what we decided to call it. Being renamed didn't make Pluto simpler. It just made people stop paying attention, and Pluto used that silence well. In 2015, a spacecraft called New Horizons finally reached it after a 9-year journey covering nearly 3 billion miles. A trip so long that the scientists who launched it had to wait almost a decade just to see if their instruments still worked when they arrived. It screamed past Pluto at more than 30,000 miles per hour. No orbit, no slowing down, no second chance. Just one narrow window to look, before it flew on into the darkness of the Kuiper Belt, never to return. What it captured in that single pass changed everything. Scientists thought they understood about Pluto. A massive, pale, heart-shaped plain of nitrogen ice stretched across a huge section of the surface, so smooth, of nitrogen ice stretched across a huge section of the surface, so smooth and so young-looking that it hinted at activity still happening right now, not something frozen in place a billion years ago. Mountains made of solid water ice rose over 10,000 feet into the black sky, frozen so hard in Pluto's brutal cold that they behave almost like solid rock rather than the soft, crushable ice we know on Earth. Layers of blue haze floated hundreds of miles above the surface, glowing faintly when lit from behind by the sun, arranged in distinct bands that told scientists something dynamic was happening in that thin, fragile atmosphere. And on Pluto's largest moon, Charon, deep reddish-brown patches stained the poles, a color nobody could fully explain at the time. New Horizons answered questions people had asked for 85 years, but it also opened up twice as many new ones, and because it only had that one pass, whatever it missed was going to stay missing. Unless something else could pick up where it left off. That something turned out to be the James Webb Space Telescope. But not in the way most people expect. Webb isn't just a camera. Its real power lies in something called spectroscopy, the ability to break light apart into its individual wavelengths and read it like a fingerprint. Every molecule in the universe absorbs and releases light at its own specific wavelength, a signature as unique as a barcode. Point Webb at a faint speck of reflected sunlight 4 billion miles away, and it can tell you what molecules are sitting on that surface, how warm different layers of atmosphere really are, and how all of it is changing over time. No spacecraft needs to travel there. The light itself carries the answer, if you know how to read it carefully enough. Here's the problem Webb had to solve first, a problem that had frustrated Pluto researchers for years. Pluto and Charon sit so close together in the sky, as seen from Earth, that older telescopes could never fully separate their heat signals. Any reading of Pluto's temperature always picked up some warmth from Charon sitting right beside it, blurring the whole picture into uselessness. It's like trying to hear one person, blurring the whole picture into uselessness. It's like trying to hear one person whisper in a crowded room. You know something is being said, but you can never quite make out the words clearly enough to trust what you heard. Webb's massive mirror and its extremely sensitive mid-infrared instrument, capable of reading wavelengths across a wide range invisible to the human eye, finally cut through that noise. For the first time in the history of Pluto science, researchers could isolate Pluto's own heat signature, completely separate from Charon's. A clean signal, a clear answer, something nobody had ever had before in nearly a century of studying this world. The team behind this breakthrough was led by astronomer Tanguy Bertrand at the Paris Observatory. Using data collected in 2022 and 2023, they published their findings in June 2025. And what they found confirmed something that had sounded almost absurd when it was first proposed 8 years earlier by planetary scientist C. Zhang at the University of California, Santa Cruz. Back in 2017, Zhang suggested something his own colleagues found hard to believe. He later admitted that even he thought of it as a wild idea. At the time, and the kind of theory you almost hesitate to publish because you expect people to laugh. His theory was this: the haze particles floating in Pluto's thin atmosphere weren't trapping heat, the way similar haze does on Saturn's moon Titan. Instead, they were doing the opposite, absorbing sunlight during the day, then throwing that heat straight back out into space as infrared radiation, faster than Pluto's fragile atmosphere could hold on to it. Not a blanket, a radiator, actively pulling warmth away from a world that had almost none to begin with. Webb's data confirmed it directly. Those tiny haze particles are running Pluto's entire atmospheric energy budget, heating up and cooling down constantly as they soak in sunlight and release it again in a rhythm nobody had ever measured before. And because of that, Pluto's upper atmosphere runs about 30 degrees Fahrenheit, colder than every existing model had predicted. Not a small correction, a fundamental miscalculation that had gone unnoticed for decades, simply because nobody had the tools to catch it. Bertrand described this as something genuinely new, not just a to catch it. Bertrand described this as something genuinely new, not just a new fact about Pluto, but a new kind of climate, unlike anything else discovered anywhere else in the solar system. On every other world scientists have closely studied, gases dominate the atmospheric behavior. On Pluto, solid particles suspended inside the gas are the ones calling the shots, quietly steering the temperature of an entire world. If you're starting to feel that itch of curiosity, that sense that this story is only just getting started, do me a favor and drop a comment with the word Pluto right now. It helps more. Drop a comment with the word Pluto right now. It helps more. People discover this video, and I want to know you're still here for what's coming next, because it gets stranger. Here's where it gets even more interesting. Pluto's atmosphere is made mostly of nitrogen, with traces of methane and carbon monoxide. That mixture closely resembles what scientists believe Earth's atmosphere looked like in its earliest days, long before life filled our skies with oxygen. Sunlight striking those ancient molecules on early Earth would have triggered similar chemical reactions to the ones happening on Pluto right now, producing organic compounds, building haze, slowly seeding chemistry across the surface, atom by atom, for millions of years before anything resembling life ever appeared. Pluto has been running that same ancient atmospheric chemistry, frozen in slow motion, for roughly 4 billion years. It isn't just a strange, distant world. It's a living laboratory, quietly preserving the exact kind of chemistry that came before life ever existed on Earth. Chemistry our own planet destroyed the moment oxygen took over and rewrote the rules of what could survive in our atmosphere. That process is also responsible for one of Pluto's most striking features, the reddish-brown material coating large parts of its surface, especially a broad region near the equator, roughly the size of Alaska. These compounds are called tholins. They form when sunlight breaks apart to methane and nitrogen molecules high in the atmosphere. The fragments recombine into heavier, darker organic compounds, which slowly drift down and settle onto the surface like a snowfall that never melts, never stops, and never has anywhere warmer to go. Tholins belong to the same chemical family as some of the molecules scientists believe helped set the stage for life on early Earth. On Pluto, that same slow production of biological building blocks has been quietly running for billions of years, settling gently onto a surface too cold for any of it to ever spark into something more. A 4 billion year snowfall of organic chemistry, landing on a world where temperatures sit close to 400 degrees below zero and nothing is ever warm enough to react any further, no matter how much time passes. Let that sink in for a second. Sunlight reaching Pluto is about 1,000 times fainter than sunlight reaching Earth. If you stood on its surface at noon, the sun would look like nothing more than a slightly brighter star in a black sky. Surface temperatures hover between roughly minus 387 and minus 369 degrees Fahrenheit. At that kind of cold, nitrogen, the same gas that makes up nearly 80% of the air you're breathing right now, freezes completely solid and becomes part of the ground itself, crunching underfoot like packed snow. The atmospheric pressure at Pluto's surface is about 13 microbars, compared to Earth's roughly 1 million. Stand there in a spacesuit, and the cold alone would start damaging exposed equipment almost instantly, long before you'd even have time to worry about breathing. Before we go further into the newest discovery, the one that's still shaking up researchers, as we speak, take a second to hit subscribe. Not because I'm asking nicely, because the next part of this story is the strangest thing Webb has found in the outer solar system so far, and you don't want to miss where this goes. In June 2026, a team led by Bruno Bezard at the Paris Observatory submitted a paper describing something they called, in unusually blunt scientific language, a detection they could not explain. While studying Webb's infrared data from both Titan and Pluto, in a narrow slice of wavelength where haze doesn't block the view of the surface, they found a dip in the light spectrum, a spot where something was absorbing light in a way that matched nothing on record anywhere in modern astronomy. They checked every documented gas, every known ice, every molecule ever recorded in any solar system body or exoplanet. Study across decades of published research. Nothing lined up with this signal. Nothing came close, and it wasn't a one-time fluke. The same feature showed up twice in the Titan data, captured by two separate instruments, months apart. That matters, because a strange result from a single instrument could easily be an error, a smudge on a detector, a fluke of calibration. But the same unexplained signal, caught independently by two different tools pointed at the same target, is far harder to dismiss as noise. Then it appeared again. This time, in Pluto, data from May 2023, at essentially the same wavelength, within the margin of measurement error, two completely different worlds. Titan, warmer, larger, with actual liquid methane lakes and rivers on its surface, a place with weather and rain and rivers, carving channels into orange-brown terrain. Pluto, frozen solid, smaller, sitting much farther out in the Kuiper Belt where sunlight barely reaches at all. And yet, both showing the exact same unexplained fingerprint in their light, as if two worlds separated by hundreds of millions of miles were quietly speaking. The same unknown chemical language. What they do share is atmospheres built from nitrogen and methane, and surface chemistry that has been quietly evolving for billions of years without any oxygen involved. Researchers have proposed a few possible candidates for what this mystery molecule might be, including certain hydrocarbon combinations and unusual ice mixtures. But none of these guesses have been confirmed. The scientists behind the discovery were careful to say exactly that. They do not yet know what this is. And in a field where researchers usually hedge their language, with caution, admitting outright that you simply don't know is its own kind of remarkable. There is a mission called Dragonfly, a drone-like lander scheduled to reach Titan in the early 2030s that could eventually help narrow down the possibilities by studying the surface up close, testing soil samples directly instead of reading them from a distance, but that's still years away, and even then, they won't directly observe this specific spectral feature. For now, this mystery molecule sits there, present on two very different worlds, matching nothing in any database on Earth, quietly waiting for someone to figure out what it is. This is really the heart of what makes this whole story so exciting. Webb didn't just add a few new facts about Pluto. It's showing us, again and again, how much has been sitting there unseen, simply because no earlier instrument was sensitive enough to separate the signal from the noise around it. Take Charon, Pluto's largest moon. Scientists had long suspected that Pluto slowly loses methane gas into space, and that a small fraction of it gets pulled in by Charon's gravity, freezing onto its poles and slowly turning into the dark reddish material New Horizons photographed back in 2015. Pluto loses roughly 1.5 kilograms of methane every second into space, drifting outward like a slow, invisible exhale. A tiny fraction of that gets swept up by Charon's gravity and frozen onto its polar caps, where sunlight and radiation gradually convert it into permanent dark organic material. It wasn't until Webb's data in 2024 that researchers confirmed carbon dioxide and hydrogen peroxide ice sitting on Charon's surface, compounds that had never been detected there before. A process people had guessed at for years, finally proven in fine detail by a telescope that wasn't even built to study Pluto in the first place. If this is starting to feel like too good a story to keep to yourself, go ahead and share it now. Send it to whoever you argue with about whether Pluto deserves to be called a planet. This video will settle that argument in ways neither of you expected. Now let's step back to what New Horizons showed us in 2015, because understanding that flyby is what makes everything Webb is finding today lands so much harder. That famous pale heart shape on Pluto's surface is officially named Tomball Regio, after the young astronomer who first spotted the world back in 1930. There's something quietly poetic about that. The man who found Pluto has his name written across the most recognizable feature on its entire surface, discovered by a spacecraft launched nearly 70 years after he first spotted that faint moving dot. The western half of that heart is a massive basin of nitrogen ice called Sputnik Planitia, roughly the size of Texas. And this ice isn't just sitting there, it's visibly churning, slowly circulating in giant convective cells, the same kind of motion you'd see in boiling water on a stove, or in the way tectonic plates shift here on Earth over millions of years. The heat driving that motion appears to come from deep inside Pluto, from the slow radioactive decay of elements buried in its rocky core, a process that generates warmth continuously, the same way it does inside Earth. Enormous polygon-shaped cells of ice, each one hundreds of miles wide, slowly turn over across hundreds of thousands of years, warm material rising at the center of each cell and cooler material sinking at the edges. A world that was supposed to be completely dead. No internal heat, no geological activity, just a frozen leftover sitting quietly at the edge of the solar system. And instead, it's still moving. Pluto has not finished cooling down, and it may not finish for billions of years yet. That internal heat leads us into one of the most debated ideas about Pluto today. The possibility that somewhere beneath the frozen crust, roughly 100 miles down, there could be a hidden liquid ocean, kept from freezing solid by the same slow radioactive warmth driving that convection up above. Nobody has directly detected this ocean. What scientists have is a pattern of clues that all point in the same direction. The cracks and ridges across Pluto's surface line, up in ways that match what you'd expect from a liquid layer, shifting slowly underneath, flexing the crust the way water pressure flexes ice on a frozen lake. Sputnik Planitia sits directly above what looks like a denser than average patch beneath the crust, a gravity anomaly. And on a world like Pluto, where the same side always faces its largest moon, heavy features naturally rotate over time to align with the strongest gravitational pull nearby. Sputnik Planitia faces exactly toward Charon, exactly where you'd expect it to end up if something dense and liquid sat beneath it, slowly reorienting the crust above across millions of years of gradual drift. Then there are the two massive mountains near Pluto's south pole, rising somewhere between 13,000 and possibly 20,000 feet, each with deep pits at their summits and flanks that look like cooled, flowing material spilling outward. If these really are cryovolcanoes, and the geological evidence strongly suggests they are, then at some point in Pluto's history, a thick slurry of water and ammonia was forced upward from a deep reservoir, all the way to the surface, erupting not fire and lava like a volcano on Earth, but freezing slush under unimaginable cold. Something warm enough to flow existed inside this frozen world, and it may still. This matters far beyond Pluto itself. Hidden oceans have already been confirmed or strongly suspected beneath the icy surfaces of Jupiter's moon Europa and Saturn's moon Enceladus. Both of those moons show dramatic surface evidence, with Enceladus even shooting geysers of water vapor directly into space, visible plumes that spacecraft have flown straight through to sample. But both are close to massive planets whose gravity squeezes and stretches them, generating the heat needed to keep their interiors liquid through constant tidal flexing. Pluto has no such neighbor pulling on it, no giant planet nearby to squeeze it into warmth. If Pluto really is hiding an ocean, it's being kept liquid purely by radioactive decay inside its own core, with no outside help at all, and if that's true, it means this kind of internal heat, something every rocky world generates to some degree, might be enough on its own to keep water liquid, even on a small frozen world. Billions of miles from the sun. That single idea could dramatically increase the number of places in our solar system worth searching for liquid water. Every large icy object out in the Kuiper Belt suddenly becomes a candidate, and there are hundreds of thousands of them scattered across a region of space we've barely begun to explore. There's one more piece of Pluto's surface that deserves attention, a region called Tartarus Dorsa. New Horizons photograph tall rows of jagged blade-like ridges made of frozen methane, some rising close to 1,800 feet high, arranged in long parallel lines like the teeth of some enormous frozen comb. Nothing like this had ever been photographed anywhere else in the solar system. Scientists believe that they form through a process similar to something called penitentes, ice formations found in high-altitude deserts here on Earth, though those only grow a few feet tall by comparison. Sunlight causes uneven melting and sublimation across the icy surface, carving tall, narrow blades, while the surrounding areas erode faster and sink lower. On Pluto, the exact same basic process is happening, just on a massive scale, using methane ice instead of water, in conditions nothing like anything on Earth, stretched out over timescales far longer than anything we can easily picture. A 2025 reanalysis of the original New Horizons data suggested these blade fields might stretch across as much as 60% of Pluto's equatorial region, an almost complete ring of jagged frozen terrain wrapping around the entire dwarf planet, hidden from full view during the original flyby, and only now coming into focus as scientists comb back through a decade of archived images. Put all of this together, and the picture that emerges is almost the exact opposite of what everyone assumed before 2015. Not a dead, frozen lump sitting quietly at the edge of the solar system, a world with active surface geology, still shifting and reshaping itself today. An atmospheric cooling system unlike anything else discovered, confirmed directly by Webb in 2025. A slow chemical factory quietly producing organic molecules related to the building blocks of life, running continuously for longer than complex life has existed on Earth. An ongoing exchange of material, with its own moon, staining Charon's poles for billions of years without anyone noticing until recently. An unidentified molecule showing up on two completely different worlds, matching nothing in the scientific record as of 2026, and strong geological hints of a hidden ocean that could make Pluto one of the most significant, quietly overlooked worlds in our entire solar system. None of this has changed Pluto's official classification. It's still labeled a dwarf planet, and that debate, which resurfaces from time to time whenever a scientist or space agency official brings it back up, is really a separate conversation from the science itself. And what the science has done is make that label feel smaller and smaller with every new discovery. The classification says small, cold, distant, unimportant. The data says something completely different: active, complex, chemically rich, still geologically alive, still producing brand new discoveries in 2026, nearly a century after it was first spotted on a photographic plate by a young man who had no idea what he'd actually found. Webb is scheduled to keep observing Pluto whenever it swings back into good viewing position, which happens periodically as both Earth and the telescope's vantage point shift over time. Every new observation adds another piece to the puzzle. That mystery absorption signal will almost certainly become a major target for follow-up study, both from more Webb observations and from laboratory experiments here on Earth, where scientists try to recreate Pluto-like conditions in a controlled chamber to see which compounds might match the signal exactly. The cryovolcanic mountains will keep being studied against the growing archive of New Horizons data, which researchers are still working through more than a decade after that spacecraft sent its final images home across billions of miles of empty space. Right now, there is no funded mission planned to send another spacecraft to Pluto. The travel time alone stretches past a decade, even using clever gravitational shortcuts around other planets, and space agencies have to weigh that against faster, closer missions that can deliver results sooner. NASA's current priorities point toward an orbiter and probe for Uranus as the next major flagship mission, with the ice giant seen as a higher near-term priority than returning to the Kuiper Belt. That might change as Pluto keeps revealing just how complicated it really is. But for now, this is the reality. Webb is the only set of eyes reading Pluto in any real detail, and it will likely stay that way for a long time to come. Which means every single observation Webb sends back from that direction matters more than it would if a new spacecraft were already on its way there. A world that was formally voted down to a lesser status. A world that sat mostly unexplored for 85 years after its discovery. A world that scientists expected to be geologically dead and atmospherically boring. Hardly worth a second glance. Once the excitement of discovery faded, that same world was supposed to be hiding nothing worth finding. Instead, it's been hiding almost everything. A world that was renamed, quietly demoted, and mostly forgotten by the public is now revealing, one observation at a time, that it has been doing things no other world in our solar system does. Some of it we're only beginning to understand. Some of it, honestly, science doesn't even have the words for yet, sitting in a paper as an unexplained absorption line, a question mark where an answer should be. And maybe that's the real lesson buried in all of this. The things we stop paying attention to don't stop existing. They just keep changing quietly, waiting for someone or something sharp enough to notice. Pluto never stopped being extraordinary. We just needed better eyes to see it. If this story changed the way you think about the little frozen world at the edge of our solar system, don't let it end here. Like this video so the algorithm knows this story matters. Subscribe so you're here for whatever Webb finds next. And share this with someone who needs a reminder that the universe is still full of secrets, even in the places we thought we already understood. Because 5 billion miles away, in the dark and the cold, Pluto is still writing its story, and we just turned the page.